Have you ever been faced with a choice, a bet, maybe a big opportunity, and you just find yourself wondering, is this risk worth taking? Well, today we are going to build the exact toolkit you need to answer that very question. Welcome to The Explainer.
All right, let's jump right into it with a simple game. You roll one die. If you hit a 6, you win 20. Anything else, and you lose 4. The question is, do you play? Now, your gut might be screaming one way or the other, but what we're going to do is let the numbers tell the real story.
So, to figure this out, we're going to go on a little journey together. First, we'll build a tool that can forecast the future, at least on average. Then, we'll need a way to measure risk. After that, we'll figure out how to translate that risk into something that actually makes sense. And finally, we'll put all those tools to work to make a really smart call.
Okay, first up is the cornerstone of our whole toolkit. You can think of this as our own mathematical crystal ball. It doesn't predict a single roll, but it tells us what's likely to happen if we played this game over and over and over again. This first tool is called expected value. In Arabic, it's called al-amal riyadi, which I love. It translates to mathematical hope. Now, this isn't what you expect to win or lose on any single turn. Nope. It's the average result you can expect over the long run. It's our best guess at whether the game is profitable or not. So, how do we calculate this? It looks kind of mathy, but it's really simple. You just take each thing that could happen, winning 20 or losing 4, and you multiply it by its probability. So the 1 in 6 chance of winning 20 gives us a positive 20 over 6, and the 5 in 6 chance of losing 4 gives us a negative 20 over 6. Then you just add them up. And would you look at that? The result is 0. Exactly 0. In the world of probability, this means the game is perfectly fair. If you played this game 1,000 times, you'd pretty much expect to walk away right where you started. No big wins, no big losses. But wait a second. Is fair really the whole story? I mean, think about it. You could have 2 fair games. One is like a calm, predictable boat ride with small ups and downs. The other could be a wild roller coaster with massive peaks and terrifying drops. Both average out to 0, but the experience? Totally different. So, to understand that roller coaster ride, we need another tool. If expected value tells us about the average, our next tool is going to tell us about the spread. It's how we start to actually measure risk and unpredictability.
So, let's bring in our next tool, Variance. This is our official risk meter. With this, we stop talking about gut feelings and we start putting a hard number on just how wild that ride is going to be. And variance? Well, it does exactly what it sounds like. It measures how much the results vary from that average we just calculated. A low variance means all the results are going to be pretty close together, very predictable. But a high variance? That means the results are all over the place. That's risk. Okay, this calculation looks a little funky, I'll admit it. But here's the key. We need this thing called e of x squared. All that means is you square the outcomes first, so 20 becomes 400 and negative 4 becomes 16. And then you find the expected value, just like we did before. For our game, that number comes out to 80. Then we just plug that into our little formula. Our variance is that 80 we just calculated minus the expected value squared. Since our expected value was 0, the variance is just 80. But what in the world is 80 dinars squared? That's not a thing. It gives us a number for the spread, sure, but it's not intuitive at all. That weird unit is our Q. We need one last tool in our kit. And this one is basically our universal translator. It's going to take that weird, abstract dinar squared number and turn it into something we can actually understand and use. And that tool is the standard deviation. In Arabic, it inhiraf al-ma'yari. Its job is so simple but so powerful. It's just the square root of the variance.
And its superpower is that when you take the square root, it translates that risk number right back into the original units. In our case, back into dinars. So check this out. We take the square root of our variance, 80, and we get about 8.94. Now this is a number we can work with. It tells us that on any given roll, the result is probably going to be about 9 dinars away from our average of 0. That's a real practical measure of the game's risk.
All right, the toolkit is complete. We have expected value to check if a game is worth playing in the long run, and we have standard deviation to tell us how bumpy the ride is going to be. So now for the really fun part. Let's put these tools to work on a brand new game.
From now on, whenever you see a game of chance, this is your 4-step plan. First, map out everything that can happen and its probability. Then, calculate expected value to see if it's profitable. Then, variance to measure the spread. And finally, standard deviation to really understand that risk. It's our complete intelligence report. Okay, here's game number 2. If you roll a multiple of 3, you win 6. If you roll an even number that's not a multiple of 3, you lose 2. Any other roll, you lose 4. Now notice how this is set up. Each of these 3 things has exactly a 1 in 3 chance of happening. All right, time to follow our plan. Step 1, expected value. We multiply each outcome by its 1/3 probability. The win gives us a positive 2, and the 2 different ways to lose add up to a negative 2. So when we sum it all up, it's 0. How about that? This game is also perfectly fair. Okay, next up, let's measure the risk. We run the numbers for variance, just like before, and for this game, it's about 18.67. Now, hold on a second. Do you remember the variance for the first game? It was 80. This number is way, way smaller. So what does that tell you about the risk? This is where it all comes together. We take the square root to get our standard deviation, and it's about 4.32 dinars. Now we can compare the 2 games. They are both fair, with an expected value of 0. But the first game had a risk of almost 9 dinars per roll. This one, less than half that. Our tools let us see something crucial that just looking at the average completely misses. So we've built the kit, we've tested it out, let's bring it all home. What's the bottom line? How do you actually use this stuff when you're the one trying to make a decision? It really just boils down to a simple 2-question process. First, look at the expected value. Is it positive? Great. The game is in your favor over time. Is it negative? It's a loser. You should probably walk away. If it's 0, it's fair. But then, and this is key, you ask the second question. You look at the standard deviation, your risk meter, and you decide if that level of risk is a ride you're actually willing to take. You know, this whole idea is so much bigger than just games. Think about it. We face these kinds of decisions all the time. Investing your money, launching a business, making a career change. This isn't just a gambler's toolkit. It's a decision-making toolkit. So my question for you is, where in your life could understanding the difference between the average outcome and the real risk give you an incredible edge?